Welcome to the Compiler, a daily curation of tech news for engineering leaders. Let's get into it. Google's recent efforts to retrofit memory safety features into their extensive C++ codebase have yielded significant results, demonstrating a practical approach to enhancing security in large-scale systems without complete rewrites. The initiative involved implementing bounded pointers, which act as a safety mechanism by preventing out-of-bounds memory accesses. This technique has led to a 10 to 15% reduction in memory safety bugs across Google's C++ projects, with some reaching up to a 50% reduction. The implementation of bounded pointers required modifications to both the codebase and the compiler. Google's custom Clang compiler was extended to support these new pointer types, allowing for seamless integration with existing code. This approach minimizes the need for manual code changes, making it more feasible to implement across millions of lines of code. One key challenge in this retrofit was managing performance overhead. Initial implementation saw a 5 to 7% increase in binary size and a similar increase in runtime overhead. However, through optimizations and selective application of bounded pointers to high-risk areas, Google managed to reduce this overhead to less than 1% in most cases. Shifting focus to streaming infrastructure, Netflix recently faced a significant stress test during the Tyson vs. Paul fight, reaching a peak of 65 million concurrent streams. This unprecedented load exposed scalability limits in their architecture, resulting in widespread quality issues and buffering problems. The incident provides valuable data for analyzing high-scale streaming infrastructures. Netflix's Content Delivery Network, CDN, designed to handle distributed load, showed signs of strain under this extreme concurrent user load. The event highlighted the need for more robust load balancing and dynamic resource allocation strategies. Specific areas of improvement likely include optimizing video encoding pipelines for rapid adaptation to network congestion and enhancing predictive algorithms for content popularity to pre-position resources more effectively. In the realm of AI development, Jakob Uskereit, a contributor to the seminal "Attention is All You Need" paper, has provided technical insights into the evolution of transformer models. Uskereit's perspective sheds light on the architectural decisions that led to the current state of large language models. One key point Uskereit emphasizes is the initial focus on encoder-only models at Google, which delayed the development of decoder-based models like GPT. This architectural choice was rooted in the belief that bidirectional context was crucial for language understanding. The success of decoder-only models in generative tasks has since challenged this assumption, leading to a shift in research focus. Uskereit also highlights the importance of scaling laws in transformer model development. The observation that model performance continues to improve with increased size and data, following predictable patterns, has been a driving force in the rapid advancement of language models. This insight has led to architectural decisions focused on efficient scaling, such as optimizing attention mechanisms and developing more effective training techniques for very large models. Turning to AI implementation in critical infrastructure, the U.S. Department of Homeland Security has issued recommendations focusing on key technical risks. The guidance emphasizes the need for robust testing and validation processes for AI systems deployed in sensitive environments. Specific recommendations include implementing AI-specific security controls, such as adversarial testing to identify potential vulnerabilities in model inputs and outputs. The DHS guidance also stresses the importance of maintaining human oversight in AI-driven systems, particularly in critical decision-making processes. This requires careful architectural considerations, such as designing fallback mechanisms and implementing real-time monitoring systems that can detect anomalies in AI behavior. Additionally, the recommendations highlight the need for secure AI model storage and transmission protocols to prevent tampering or unauthorized access to these critical components. Thanks for listening. For more, please visit thecompiler.io.